We're going to look at combustion in this video, combustion of hydrocarbons specifically. So first question, probably fairly obvious, or hopefully fairly obvious. So why do we burn hydrocarbons? And this is a very, very long answer. There's only 2 lines here, so we can be brief. But you know, there are many reasons. Good source of energy. They're cheap, readily available. Easy to transport. You know, the list goes on. There are plenty. Basically, we need energy as a human race to live the lives that we want to live. So, cheap sources of energy are really, really crucial to us, and this could go on forever. You know, let's move on to the time. Most of the fractions of crude oil are used as fuel. So crude oil, okay, most of those bits in crude oil are used as fuels. Predict what the products of complete combustion of methane are. Methane, of course, is our first member of the alkane family. It's the smallest hydrocarbon because it's just got one carbon in it. There's methane, and that's a gas. Okay, right, so word and balancing the equation for this reaction. Okay, before we do that, let's just have a think about what combustion is. So what are the words linked to combustion? Now, when I ask that in a class, everybody says burning, but I'm not interested in the answer burning. What I'm after is the answer oxidation. Now, you can have oxidation that isn't combustion, but combustion is oxidation. Oxidation is reacting with oxygen in a basic definition. So if we're going to take methane and burn it, we're going to react it with oxygen, methane plus oxygen. So that's the start of our word equation. So methane is CH4 and oxygen. Now remember, oxygen is O2, not O. Okay, so you probably get a mark in the exam if you wrote that. If you write CH4 plus O, you'd get a 0 for balancing this equation. Now, burning is oxidation. So we're going to oxidize this methane. So methane is made of carbon and hydrogen. So we're going to split this apart and oxidize it. So carbon and oxygen, a prediction could therefore be carbon dioxide. And again, students I teach are pretty good at telling me carbon dioxide. I then say, okay, so what's the other product? First rule of chemistry, of course, is what you start with, you must finish with. We've oxidized the carbon, what's the other product? And people would tell me hydrogen. Okay, hydrogen's not right. Okay, hydrogen on its own is a massively explosive gas because it burns so readily. So the hydrogen's going to oxidize as well. So what's the product? What's hydrogen oxidized? Okay, the answer often given is hydrogen oxide. Hydrogen oxide is not wrong, but it's not the best answer because, of course, hydrogen oxide is water, H2O. So there is our prediction of reactants and products. We now need to balance this equation. So 1 carbon there, 1 carbon on the right. So we need to have the same number and type of atoms on the left and right of the equation. Got 1 carbon on both sides. 4 hydrogens, got 2 hydrogens there. So we can put a big number 2 there. 2 times 2 is 4 hydrogens. That's 4 hydrogens on both sides. O2 on this side. Now on the right hand side, how many oxygens are there? Well, often I'll ask this and somebody will say only 2. That's because they're looking at this, but they're forgetting there's oxygen here as well. So they then change their answer. They change their answer to 3 because they see the O1, but they've forgotten this 2 in front of the water, which changes that 1 to 1 times 2. So we've got 2 oxygens there and 2 oxygens here, so 4 oxygens. So we need 4 oxygens on this side, so we need to put a 2 there. Okay, and there's our prediction of the products of complete combustion of methane, assuming all the methane oxidizes. How can we test for product 1? Well, let's say this is product 1, carbon dioxide, lime water. Lime water. Lime water turns milky or cloudy. Milky or cloudy. Now you only need to say 1, okay? Milky is the one I usually use. Lime water turns milky if CO2, carbon dioxide, is bubbled through it. One of the examiner's favourite questions to ask that. Help if I could spell through, wouldn't it? Through it. Okay. So we need to learn that. That's absolutely essential. Learn, right? That's on your specification. Product 2, water. Okay, this is not, don't learn this, this is not on your specification, okay, don't learn. Okay, we're going to use cobalt chloride paper to test for that. Cobalt chloride turns from blue to pink, So this is not on your specification, okay, this test, so don't learn it. The only reason we're doing it today is because we just want to look at how we can test that our prediction is correct. Okay, so it's a good thing to do because the products of complete combustion are definitely on specification. That needs learning. They absolutely need learning as well. Okay, so we're just going to test it. Okay, and to test it, we're going to use this apparatus. So this is paraffin wax. Paraffin is a fairly long chain alkane. Okay, same homologous series as methane. It's just very easy for us to use. Okay, so that's made of carbon and hydrogen only. So we're going to burn that, oxidize it, and we're going to suck the gases that come off through this. I mean, let's just go back for a second. Let's put state symbols on this. Methane was a gas. Oxygen's a gas. Carbon dioxide is a gas. That's the state symbol of water. But a lot of people tell me liquid because they think water's a liquid. Water is a liquid, and they're right to say that. But of course, this is combustion, this is burning, this is hundreds of degrees. So any water that comes off this is not going to be water liquid because water boils at 100 degrees. So the water that comes off is going to be a gas as well. So we need to suck these gases off through this apparatus. Okay, now the first thing we test for is the water vapour, cobalt chloride. So that's the cobalt chloride, which you don't need to learn for the exam. Okay, and then after we've tested for the water, it's important we test the water first because we're going to bubble the gases through lime water. Next, this is lime water here. That's the test for carbon dioxide. That's the one you need to learn. That's the test for CO2. If we were to bubble, if we were to put the lime water here and bubble the gases through that lime water, any water would get stuck in there, wouldn't it? Because the lime water is obviously cold, so any water vapour would condense in there. So it's important we test the water vapour first. Purpose of the candle, well, that's the hydrocarbon. That's what we're doing the complete combustion on. Okay, why is the U-bend before the boiling tube? This is the U-bend. Why is it before the boiling tube? Well, we want to need to test. We need to test for water before we bubble the vapours through the lime water. Okay, next question. What was the result of the experiment? So if we do this experiment, okay, the lime water turns milky or cloudy equals CO2 present. Okay, the cobalt chloride, which you don't need to learn, turns pink, turns from blue to pink, equals water present. Okay, so what we can make from that, the conclusion from that, the conclusion is carbon dioxide and water are products of complete combustion.